The moon, Earth's faithful companion, has captivated human imagination for millennia. Its enigmatic beauty has inspired countless myths, stories, and scientific endeavors. In this video, we will delve into the history of lunar exploration, understand why we're returning to the moon, explore the role of private space agencies, examine the moon's resources, and envision the future of human presence on our closest celestial neighbor. Past lunar missions, one small step. The exploration of the moon has been an enduring dream for humanity. One of the most iconic and pivotal chapters in lunar exploration was NASA's Apollo program, which spanned from 1969 to 1972. This ambitious undertaking saw a total of 6 manned lunar landings, with astronauts setting foot on the lunar surface, conducting experiments, and collecting valuable samples. The Apollo missions, particularly Apollo 11's historic landing with Neil Armstrong and Buzz Aldrin, marked a significant leap forward in our understanding of Earth's satellite. Not only did these missions provide stunning visual and scientific insights into the moon, but they also helped unravel the mysteries of our own planet's history. By studying lunar rock samples, scientists discovered that the moon is approximately 4.5 billion years old, nearly as old as the Earth itself. This insight provided crucial clues about the early solar system's formation and development. Long break from lunar exploration. After the Apollo missions, lunar exploration took a back seat as space agencies turned their attention to exploring other planets, such as Mars and the outer solar system. This hiatus was due to various factors, including budget constraints, geopolitical priorities, shifting scientific priorities, and the complexities of maintaining human missions to the moon. However, even during this period, robotic missions continued to orbit and study the moon, providing valuable data about its surface composition, mineral resources, and gravitational characteristics. These missions laid the groundwork for future lunar exploration and helped maintain our connection to our celestial neighbor. Back to the moon. Recent missions after 2010. In recent years, lunar exploration has experienced a resurgence. NASA's Artemis program, named after the twin sister of Apollo in Greek mythology, aims to return humans to the moon's surface by the mid-2020s. The program's objectives include establishing a sustainable lunar presence, conducting scientific research, and preparing for future missions to Mars and beyond. Artemis represents a new era of international collaboration, with plans to include the first woman and next man on the lunar surface. China's Chang'e series of missions has also made significant contributions to lunar exploration. Chang'e 3, for instance, successfully landed a rover named U2, or Jade Rabbit, on the moon in 2013, becoming the first soft landing on the lunar surface since 1976. Subsequent missions, including Chang'e 4 and Chang'e 5, furthered our understanding of the moon's geology and resources. There have been several missions to the moon after 2010, launched by different countries and agencies. Here are some of the most notable ones. On October 1, 2010, China launched its second lunar orbiter mission, Chang'e 2. It fulfilled its lunar mapping objectives before departing towards the Earth's Sun L2 Lagrangian point to put the Chinese tracking and control network to the test. In 2012, it also flew by asteroid 4179 to Tatus. The Artemis P1 and Artemis P2 spacecraft were initially part of NASA's Themis program to explore the Earth's magnetosphere. In 2010, they were guided to lunar orbit, making them the first spacecraft to orbit the moon's Lagrangian points. They investigated the plasma environment and magnetic field of the moon. On July 22, 2019, India launched its second moon mission, Chandrayaan 2. It was made up of an orbiter, a lander, and a rover. Due to a loss of control during the final phase of descent, the lander fell onto the moon's surface, but the orbiter is still operational and gathering data on lunar terrain, mineralogy, and water ice distribution. On November 23, 2020, China launched its fifth lunar mission, Chang'e 5. It was the first mission since 1976 to return lunar samples to Earth. On December 16, 2020, the mission successfully retrieved roughly 2 kilograms of rocks and soil from a previously undiscovered location near the moon's North Pole and returned them to Earth. Artemis 1 was launched from Florida's Kennedy Space Center on November 14, 2021. It was the inaugural mission of the Artemis program, which intends to place the first woman and next man on the moon by 2024. During the 25-day mission, Orion orbited the moon twice and conducted different experiments and measurements. The mission also included the deployment of 10 CubeSat satellites for scientific and technological purposes. Orion's mission came to an end successfully on December 9, 2021, when it crashed into the Pacific Ocean. On July 14, 2023, India launched its third lunar mission, Chandrayaan 3. It was a carbon copy of Chandrayaan 2 minus the orbiter. On August 23, 2023, the lander and rover successfully landed near the moon's south pole. The mission recently conducted experiments and measurements on the lunar surface. It is also the first mission to land a spacecraft near the lunar South Pole. Why everyone is returning to the moon. The renewed interest in lunar exploration is driven by a combination of scientific, strategic, and practical factors. Firstly, the moon serves as a unique laboratory for studying the early solar system and the history of Earth. By examining lunar rocks and geological formations, scientists gain insights into the fundamental processes that shaped our planet. Secondly, the moon represents a crucial stepping stone for future deep space exploration. It offers a relatively close and accessible location for testing technology, conducting experiments, and gaining experience with long-duration space missions. This experience is invaluable for preparing for eventual crewed missions to Mars and other distant destinations. Lastly, the moon is viewed as a potential source of valuable resources. Water ice, particularly in the lunar poles, can be converted into drinking water and used for producing oxygen and hydrogen for rocket fuel. Additionally, the moon's regolith, or surface material, contains rare elements like helium-3, which could potentially be used in future fusion reactors. Exploration of the moon by private space agencies. Private space agencies have become significant players in lunar exploration in recent years. Companies like SpaceX and Blue Origin have ambitious plans for lunar missions. SpaceX, led by Elon Musk, envisions using their Starship spacecraft to transport humans and cargo to the moon and potentially establish a lunar base. This approach aims to reduce the costs of lunar exploration and make it more sustainable in the long run. Blue Origin, founded by Jeff Bezos, has its own lunar ambitions through its Blue Moon Lunar Lander project. They intend to provide transportation services for lunar missions and cargo delivery, opening up new opportunities for scientific research and resource utilization. The involvement of private companies in lunar exploration is not only accelerating progress, but also fostering competition, which could lead to innovative solutions and cost-effective missions. Public-private partnerships are increasingly shaping the future of lunar exploration. Future exploration of the moon. The future of lunar exploration is exciting and multifaceted. International collaboration is a key theme, with space agencies from various countries working together on lunar missions. NASA's Artemis program aims to establish a sustainable human presence on the Moon, starting with the Artemis 3 mission that will return astronauts to the lunar surface. China is also planning to put a crew on the Moon in the 2030s. One important aspect of future exploration is the establishment of lunar bases. These bases will serve as hubs for scientific research, resource extraction, and staging points for missions to other celestial bodies. The lunar environment also provides a unique opportunity for testing technologies and systems that will be vital for future deep space exploration, including Mars missions. Robotic missions will continue to play a crucial role. These missions will explore uncharted lunar regions, study lunar geology, and assess the Moon's suitability for human habitation. Advances in robotics and artificial intelligence will enable autonomous exploration and data collection, even in the most challenging lunar environments. Resources on the Moon. The Moon is a treasure trove of resources that could prove invaluable for future space exploration and even support life on the Moon itself. Water ice is particularly abundant in the permanently shadowed craters at the lunar poles. This water can be used for drinking, oxygen production, and hydrogen fuel for rockets. Access to water on the Moon reduces the need to transport these resources from Earth, making lunar missions more sustainable. Another resource of interest is helium-3, a rare isotope found in lunar regolith. Helium-3 is a potential fuel for future fusion reactors, offering a nearly limitless and clean source of energy. While fusion technology is still in its experimental stages on Earth, the Moon's abundance of helium-3 could drive future energy solutions both on the Moon and back on Earth. What the Moon can be to humans in the future. The Moon holds immense promise for humanity's future in space. It can serve as a stepping stone to further exploration, providing a platform to test technologies, conduct research, and develop the infrastructure needed for a sustained human presence in space. The lessons learned on the Moon will be invaluable as we plan for missions to Mars and beyond. Moreover, the Moon has the potential to become a hub for space tourism and commercial activities. Lunar tourism, though in its infancy, could become a reality, allowing civilians to experience the lunar surface and contribute to the economic viability of lunar exploration. Moon base and future colonies. The establishment of lunar bases and colonies is a natural progression in our exploration of the Moon. These bases will not only support scientific research, but also serve as outposts for resource utilization and further exploration of the Moon's diverse regions. Over time, they may evolve into sustainable colonies where humans live and work for extended periods. Building a lunar base presents unique challenges, including radiation protection, life support systems, and sustainable resource management. However, overcoming these challenges is essential for humanity's long-term presence beyond Earth. Lunar colonies could serve as testbeds for developing the technologies and practices necessary for future colonies on Mars and beyond, ushering in a new era of space exploration and expansion. The Moon represents a beacon of hope and possibility for humanity's future in space. As we continue to explore and understand our celestial neighbor, we open the door to exciting scientific discoveries and the potential for humans to establish a lasting presence beyond Earth. The Moon, with its rich history and promising future, beckons us to continue our journey into the cosmos. Thank you for watching, and please subscribe to the channel.